I'm Nishadi Gunasinghe and this is my demo video for dissertation of my master's program in Information and Technology. I'm going to introduce a novel hybrid compression model for real-time streaming text data. Streaming data has its own characteristics such as continuous data flow, large volume, and needs to be processed in a real time. Therefore, a powerful compression algorithm is a great necessity of streaming data. So, I have conducted a qualitative analysis from the existing literatures of traditional compression algorithms and compression mechanisms for streaming data. But I have noticed that compression speed is not considered as an important performance parameter of those mechanisms. But the compression speed is more important as compression ratio when the compression model is using for a real-time streaming data. Therefore, introducing a novel hybrid compression model for real-time streaming data, real-time streaming text data with the high compression ratio and the high compression speed is the aim of this research. Therefore, after critically analyzing the existing literatures, 5 algorithms such as LC4, GZIP, LCMA, ZSTD, and BC2 were selected to create a new hybrid compression model. These algorithms also have some advantages such as good compression speed, also have some limitations such as lower compression ratio. Then I have selected 5 different data files with different type of text data, such as mostly have the numeric data, mostly has the repetitive data or a mixed type of data. So to develop a high performance compression model, I have tested 20 pairs from these selected algorithms with the 5 different data files and measured the compressed file size and the compression speed. The pair of BC2 and ZSTD was well performed for the all data inputs, and here I show you some of the obtained results. Therefore, the next task was to improve the performance of the selected pair. I have chosen that BC2 and ZSTD for our hybrid model. So also I have identified that nature of the data and the file size can impact to the performance of the compression model. Therefore, I tried to find a benchmark of the file size. For that, I have tested 100 kilobytes to 1 megabyte chunks as the input of the first BC2 algorithm and used that compressed output as the input of the ZSTD algorithm. According to the obtained results, 400 kilobyte chunk scenario obtained the lowest compressed file size in the lowest time for the most input file. Therefore, initial compression model was built up with the 400 kilobytes chunks as its input file. So here is the initial compression model. It reads the input file and split the input file into 400 kilobyte chunks and fed these chunks to the BC2 algorithm, and the compressed output of the BC2 algorithm is used as the input of the ZSTD algorithm and get the overall output as the compressed chunks. Then I have identified that the second ZSTD algorithm did not well perform. So I have investigated on it and found 2 root causes of this matter. The first one is the compressed chunks of the BC2 algorithms was too small, and also that was a binary file. Therefore, the compression model was updated to eliminate these problems. Now, the updated model is read the input, split, and use as the input of the first algorithm as same as the initial stage of the compression model. Then, I encoded the compressed chunks using the base 64 encoding. Then concatenated these encoded chunks using pipe character to create a one single file. The reason is to choosing this pipe character is not using the process of base 64 encoding, and we can easily identify these concatenated chunks in the later processes. Then check the combined file is larger than the 400 kilobytes or not. If yes, then again split this file into a 400 kilobyte chunks and fed it to the ZSTD algorithm. Otherwise, send the compressed chunk of the first algorithm as the compressed output of the compression model. Then the configuration parameter of BC2 and the ZSTD algorithm identified as a performance impact variables. So investigated with them and compression level 5 of the BC2 and the compression level of 0 of ZSTD identified as a benchmarks of the hybrid compression model. Well, the next task is to adapt this model to the data streams. Therefore, the model is updated to read data in each second from the one central location. Then check this data file is greater than the 400 kilobyte. If yes, send it to the compression as discussed in the previous section. And otherwise, no need to waste the computational power for the compression and send this small file as a small files to the data stream directly. Then the next task is to build up the decompression model. There are two levels in this decompression process. The first one is if the compressed chunk is compressed only with the first algorithm, that means the BC2 algorithm, it only decompresses with the BC2 algorithm. Otherwise, if the compressed chunk is decompressed with the two algorithms and the encoding as well, so we have to decompress, uh, we have to do this decompression process as the reverse of the compression process. Therefore, first we decompress with the ZSTD algorithm, then combine those all chunks into one file and split that one file with the pipe character, and those chunks are decoded by the base 64 decoding. Then these decoded file chunks are decompressed with the BC2 algorithm and again combine these decompressed files to create the original file and return it as the output file from the decompression file. Therefore, identifying this level of compression was a challenge. So, the product prototype was designed to eliminate these problems. Basically, the product prototype was designed with the three services such as data generator, compression service, and the decompression service. So, this data generator is responsible for collect data from any data generated device or a service and send them to the shared location which can access by the compression service. Meantime, this data generator service will send some metadata to a queue to identify the data files from the shared location. So, the compressed service is designed with the three components with the single responsibilities. These scheduler trigger an event in each second to the file handler. Then the file handler get the file name through the file names through the stream handler and read the file from shared location and pass this pass this file to the compressor to compress the data as discussed in the upgraded model of the compression. Then the file handler send the compressed chunk to the stream handler and stream handler send this data to the data stream. Meantime, stream handler will add some metadata to identify the compressed level of this each chunk to this queue. So the decompress service is also designed as same as the compressor service. It also has the same responsible components such as file handler, stream handler, and the decompression handler. So the stream handler gets the metadata from the queue and read the related data file from the data stream. Then the file handler passes those compressed files and the metadata to the decompressor, and it will decompress the data as discussed in the uh, sorry as discussed in this compression model. So now he knows the level of the compression of each chunk. Um, then the file handler uh, passes those compressed chunk. Sorry. Then the file handler passes the original output file to the outer world by this compression model. So then I have implemented this design. Here I have implemented three services using Python coding language and use Docker and Docker Compose to deploy those services. Then I have used a local stack environment to simulate the cloud environment. Also, I have used the AWS SQS FIFO queues and the Kinesis data stream to implement implement these two queues and the data stream as discussed in the design. So now I will show you how my code base work. Well, here you can see my three services: compress, data generator, and decompress service, and their components with single responsibilities. And also, I have created this YAML file to generate these services and to start these services and the local stack environment as well. So I will start the local stack environment first. Well, it's working now. Then I will start the data generator service. Here I have used a local file path as a shared volume and mount it to using the uh, compressor service as a Docker container. So yeah, now it's running. Now here we can see some generated data files are in the shared volume. Then we will start the compress service and the decompress service. So I have created the report. I have generated a report to see the compression performance and the decompression performance, and we'll wait for the report. Here we can see it was generated, and we'll try to open it. Yeah, here you can see the original file size is 14.6, but it compressed to the 1.02 megabytes in the 1.78 seconds. So will see the decompression performance as well. So yeah, the decompressed file size is also as obtained as the 14.6 megabytes, and it will only used 0.39 seconds to achieve all the decompression service by this new compression model. Then I have compared the novel compression model with its originated BZ2 and the ZSTD algorithms. So for that, I have run these all services locally. Here you can see the novel compression model obtained a significantly higher compression speed than the BC2 and the considerably higher compression ratio than the ZSTD algorithm. These BC2 and the ZSTD performance performance values are obtained with their default configuration parameters. Then I have tried to obtain the lower compression time uh, as the novel compression model by the BC2, but it's only obtained the 1.62 seconds as its higher speed, and at that point it will increase its compressed file size as well. Also, I have tried to achieve the lower compressed file size as a novel compression model by the ZSTD. It reached the some compressed file size, but it used 10 seconds to achieve that compressed amount. Therefore, this novel model is achieve higher compression ratio and the higher compression speed than its originated BC2 and the ZSTD algorithms. But this compression speed can be vary with the processing power of the machine, And also compression ratio can be vary with the nature of the input data. But this novel hybrid compression model will perform at these any scenario well performed with this any scenario rather than its originated BC2 or a ZSTT algorithms in the same condition. So that's all I have. That's what I have to share with you in this video, and I will end up with here. Thank you.